I'm Nicholas Thompson. You're listening to The Most Interesting Thing in AI, a podcast produced by Atlantic Rethink, the Atlantic's creative marketing studio, in collaboration with PwC, a leader in helping organizations use AI. In each episode, we're exploring how artificial intelligence is reshaping our lives and redefining what's possible. Today's guest is Andrew Ng. He's been at the center of AI development for decades. As a professor at Stanford, he's taught popular IRL online courses that have introduced a generation of students to the fundamentals of machine learning. He's also had important roles in the business world. He was a co-founder of Google Brain, chief scientist at the Chinese company Baidu, leading the AI group. His current projects include the educational tech startup DeepLearning.AI and a venture capital firm, the AI Funds. Through all of this, Andrew has found the time to author or co-author more than 200 papers about robotics, model training, and many other things. And I should add, he's an excellent person to follow on social media. Recently, a tantalizing question has emerged in the AI field. Up to this point, when it comes to training AI models, the more data you have, the better the model performs on reasoning and inference tasks. But there are reports that the next generation of models has kind of hit a wall, and that we might not expect AI capabilities to continue to scale as they have in the past. So I was excited to talk to Andrew about this. You'll hear us refer to it as scaling laws, and about the pace and the future of AI development. Our conversation covers a lot of ground and could not be more timely. Let's get started. Andrew, it's wonderful to be here with you. How have you been?
Good. It's always great to see you, Nick.
Let me start off by asking a general framing question, which is, to a lot of people, AI is something that sort of blew up or entered their world 2 years ago. You've been in the field for 20, 25 years. You've been a pioneer in the field. What does this moment feel like to you? Does it feel like we've been on a steady curve? Does it feel like we've been on a curve with a major inflection point 2 years ago? Does it feel like we're on a steady curve that is going to have a major inflection point coming out? What does the moment feel like to you?
I'm going to give an answer that may be an unpopular minority view.
Excellent.
I think PR hype tends to come in spurts, and societal awareness of technologies can shift suddenly. I think that's what happened in the last few years. From a raw technology point of view, I feel like AI technology has been, steadily advancing, making significant progress year on year for the last 20 years. But it turns out that if something grows, let me just make up a number. If something grows 50% year on year for 20 years, that is exponential growth. And so to outsiders, it feels like it came out of nowhere. I would say the raw technology has been advancing for a long time, but together with this rapid shift in societal awareness has been an explosion of attempts to use this technology to build tons of new applications. And so that's been really exciting as well.
That's super interesting, because if that's the case, it also suggests that the rate of change we've seen over the last period of time may just continue. It may just improve at whatever the rate of change has been for the last 10 years, for the last 20 years into the future. And since we're at a more advanced point right now, the effects will feel even more profound, right?
I hope you're right. It does feel like AI technology is continuing to advance. There's a lot of hype about scaling laws. Some of the hype is justified, but this idea of building bigger AI models with more data, and that would drive progress. And I think a lot of the media headlines has focused on that because it does cost billions of dollars to keep on doing that. But there are multiple vectors of AI progress right now, regardless of whether scaling laws, building bigger models by itself will drive more progress. I'm confident that AI technology, that is generally our ability to write AI software, to have it demonstrate intelligent behavior, I'm confident that that will continue to advance at a rapid clip for the next few years.
Wait, so you just said something extremely interesting. It sounds like what you're saying is that you don't believe that scaling laws, which is a kind of term used in the industry for the observation that as you increase the size of models, you increase the power of them. You don't believe that that is really the underlying cause of the progress we've seen recently?
Oh, I think it's been a huge factor in the progress. I think it is a major cause of the recent past few years of progress. In fact, it was actually my old team at Baidu that I led that published, I think, the early version of scaling laws. And I think OpenAI did wonderful work doing it in a more systematic way. But it is absolutely true that building bigger AI models on more data has driven tons of progress. I think the recent debate has been, will scaling laws continue to work and how expensive will it be? And I think it will continue to work for a little bit longer. It's just that part of scaling laws is it gets exponentially more expensive to keep on scaling this way. So I think that lemon maybe has a one or two more squeezes in it. But I'm not concerned about scaling laws eventually being too expensive to keep scaling because there are other vectors by which AI technology is advancing.
This is one of the things I like most about interviewing you is that you've just very calmly positioned yourself in a quite different position from a lot of people in this debate. There are people out there, Dario Amodei is the example at the moment, and he said, look, scaling laws have existed for a long time. They'll continue. We'll figure it out. And there are other people on the other side who say, scaling laws aren't working anymore. They're going to slow. That means progress is going to slow. And if I'm hearing you correctly, you're saying, well, scaling laws aren't going to work that much longer, one or two more squeezes of the lemon, but we'll just figure other things out. Is that a correct attribution of your argument?
That sounds reasonable. But Dara was on my team at Baidu, and he was actually sitting right next to the team at Baidu that published the first version of scaling laws kind of before OpenAI. And I think that he's largely been right in the way he built Anthropic. And maybe just to give one example, if you were to ask me what is the most important AI technology today that's advancing, I would say is AI agentic workflows. And what that means is right now, a lot of us will prompt a large language model to generate a response. And that's a bit like asking a person or an AI to write an essay by typing the whole essay by writing from the first word to the last word all in one go without ever using backspace. And, AI surprisingly can write decently well like that. But it turns out that if you ask an AI to write a draft, read this draft, critique it, work on it, do online research, really iterate on it, work on it multiple times the way that, say, a human writer or editor would do, then AI does much better. It takes longer, but letting AI work and rework as material gives a much better work output. So agentic workflows, which refers to these iterative AI processes, are making its way into more and more applications. Fortunately, it doesn't cost billions of dollars to implement this. The fact that it doesn't cost billions of dollars also means it's garnered less newspaper headlines, for example, but this is an important technology. Agentic workflows refers to how AI developers will often call an LLM, prompt an LLM multiple times to get it to do multiple steps to complete a task, such as to write a research paper, let's brainstorm an outline, then brainstorm what web searches, then download a bunch of web pages, and then write a first outline, and then write a first draft, and so on. So that's one example of an agentic workflow. Or to process a tricky legal document, we may first find the definitions, and then find the terms, and then process that, and so on, to eventually reach a conclusion. Maybe a little bit like the way a human lawyer would break down the tasks of a complex legal analysis into a step-by-step analysis. And so our ability to implement these type of complex workflows, we call them agentic workflows, is letting us do a lot of tasks with AI that were not possible before. And OpenAI's model, the O1 preview, was one way to do a slightly different iterative workflow where you can ask the AI model to think through a task, and a single call to AI model will have it, think or really write text, generate a lot of thought for maybe seconds or tens of seconds before it then gives a very high quality output to you.
It's a super interesting phenomenon. Will we have to retrain models or build them differently as we move into a world of agentic workflows as opposed to the more direct ones we're used to?
Yes. This has been an exciting, small but growing trend in the use of AI models as well. So if you look at the data used to train AI models today, technically the instruction tuning data, but a lot of people go to ChatGPT or Gemini or Claude and ask it questions. And so a lot of the data used is to train an AI model to answer a question and be maximally helpful, say, in answering different questions people have. But it turns out that their efforts to train AI models not to answer a question a human have, but to have the AI model fit into part of a longer iterative agentic workflow. And maybe one example of this is Anthropic recently released a set of tools for computer use where you can have an AI model try to take control of a computer, really a virtual machine, and look at your monitor, bring up a web browser, click on the web browser, type text in the search bar. So really have the AI model use a computer to search and get things done. And this is an example of an AI model that has been trained to fit in part of an agentic workflow where if a computer program wants to use this AI model to do some robotic process automation tasks, this is an exciting step in that direction. And I think that in the next period of time, we will see more and more large language model, AI model capabilities that are trained not just to answer a question that a human may type into a website, but to fit into these types of agentic workflows where software is trying to get the model to do a task that requires taking a long sequence of steps.
Right. And do you think that's making the AI models more like us?
Analogies between AI models and humans has always been dangerous territory.
Absolutely. But it's also very fun territory.
Yes, it is fun territory, but dangerous. I think they're certainly making them more like us in the sense that humans don't do everything by blurting out an answer and typing from the first character to the last character.
Right.
I think, and then we output the final output. So getting AI models to do that, it really makes a lot of sense, and it makes us more like us in that one dimension.
Right. So in that one dimension, they're more like us. Let me go back to something that we were talking about just a minute ago, which is your hypothesis that scaling laws will end fairly soon or they'll be less prominent fairly soon, but that other things will lead to major progress. Besides the shift towards agentic models, are there other changes coming in AI that you think will be transformative and that will push the field forward even as scaling law becomes less important?
It's not that scaling laws are unimportant. They will continue to work. I hope they'll still continue to work, for a few years. But the thing that's not widely appreciated is they get exponentially expensive to keep on scaling that way. So one of the exciting trends is because of semiconductor and software innovations, the cost of training these models is falling rapidly. I think there's some estimates that maybe training a model, of a certain size falls in cost by, I don't know, let's say 75, 80% a year. So that's actually great and very democratizing. If things get 5 times cheaper, but you decide you want to train a model that's, 25 times bigger, then it still gets more expensive. I think is not as bad as widely feared, because in terms of moats, business moats, this is a moat that seems to keep on shrinking, at least in terms of access to compute.
So how many kind of equivalently powerful frontier models will there be in 3 years? Will there be 7 or will there be 100?
I wish I knew. That's a very good question. If scaling laws keep on working, they'll be close to the 7. But if scaling laws tap out, then I think there'll be more. I think in a couple of years, there will still be a relatively small number of absolutely cutting edge frontier models because of the massive capex that we're still seeing go into that. But one of the positive things about this is I know because of the billions of dollars spent in AI, and in fact, Sequoia Capital has a very thoughtful article titled, I think, AI $600 billion.
Yeah, it's an amazing article.
It points out that to justify the capital expenses in buying GPUs and data center buildouts, someone had better find $600 billion of revenue to justify this. What is less widely appreciated is that I think the economics of the foundation model trainers is very challenging because of this reason. But it turns out because, the foundation model trainers have spent billions of dollars training these models, this is great for the application builders. And when someone else spends $1 billion to train a model and then offers an incredibly cheap API call or even releases a model free on the internet that they spent $100 million to train, then for those people wanting to build applications. So people that don't want to compete with OpenAI and Anthropic, say, but if you want to build a medical diagnosis application or build a marketing application or build a AI teaching assistant or whatever, it's now very capital efficient to do that. And so this is actually wonderful for all the application builders.
I mean, again, that's a somewhat controversial argument. I mean, there are a number of people out there who believe that most of the value in future AI will accrue to the base foundation models, in part because when you build an application on top of, say, Anthropic or OpenAI, you have a relatively limited moat. You have to figure out whether your moat is UX, whether your moat is proprietary data, whether your moat is marketing, but your moat isn't going to be as deep as it would be if you had built the base layer.
So first, in terms of net revenue, total revenue point of view, the applications had better generate more revenue than the foundation model because we need the applications to generate even more revenue for them to be able to afford to pay the foundation model builders. So on that metric, I think the applications had better be even more valuable. from a business value point of view, whether or not the value accrue more to the applications layer or to the foundation model layer would be more a function of market power. So maybe to make an analogy, a lot of the value in mobile accrued to, Android and iOS, Google and Apple, because the two companies wound up being really, frankly, gatekeepers of the entire mobile world. And so were in a position to capture a lot of the value from mobile. In the case of foundation models, if there are enough open source, open waste models so that they don't end up being really harsh gatekeepers of the foundation model layer, then I think that a lot more value will be captured at the application layer. What you just said at the application layer is maybe this idea of, are companies just building thin wrappers on top of ChatGPT and how is that business defensible? What I'm seeing is for a lot of consumer applications, it is hyper competitive. There are some businesses that are doing well. What GitHub Copilot is doing well, Cursor seems to be doing well, Perplexity has a lot of momentum. So there is a handful of consumer applications that have managed to stand out, but it is hyper competitive as well because once someone builds a working consumer application, turns out a lot of your users will be engineers, and some of those engineers will go, oh, well, I could build the same thing myself in a week or a month or whatever. Which is why I don't even remember, like a year and a half ago, there were all these chats with PDF applications, which is an innovative thing. Upload a PDF file and ask questions, but that's just hyper competitive and non-differentiated at this point in time. So there will be some consumer standouts, but it's challenging. What I'm seeing in B2B applications, my team AI fund works with a lot of large enterprises. And when we use AI to help manage large-scale energy infrastructure or to deal with complex government compliance paperwork or whatever, it turns out a lot of these applications, I think they're wildly exciting and sexy, but many engineers don't think they're wildly exciting and sexy. And then also, the typical person doesn't have access to, say, large-scale energy infrastructure. And so I find that in the enterprise space, we're often able to build and launch applications. And then I'm sure competition will come eventually, but there isn't nearly that intensity in the B2B space as I see in the B2C space.
Super interesting. Let's go back to, I want to talk a little bit more about open source, but I also want to talk about one of the craziest things I've been reading about recently, which is decentralized training. And the notion there is that instead of getting a huge cluster of computer chips and training your AI model on them, you could do it in a decentralized way. You could have one person with a computer in one country, another person with a computer in another country, or a cluster of computers, and train a pretty efficient AI model that way. And if that happens, it could change the whole competitiveness of the market and raise all kinds of complicated regulatory issues. Do you think that decentralized training will be a real thing?
So decentralized training, sometimes we call it federated learning. It's been an exciting R&D topic, and I'm seeing very small scale early signs of customer traction. My team, DeepLearning.AI, did some work with Flower, which provides infrastructure for federated learning or decentralized training. And I think there are important use cases where if you want to train on medical records, but hospitals can't release their records, then maybe every hospital can train a bit and you have a central model. I think iOS, uses decentralized training as well to do some things, that doesn't require your data to be transmitted off your cell phone to Apple. So I think there are some use cases. The technology is challenging. For training the largest AI models, the foundation models, centralized training is just so much easier to work. In fact, the way we train large foundation models often requires very high-speed networking in a single data center. So getting that to work in a very decentralized way seems challenging. But I think there are a few applications, especially ones with privacy implications, where I see, a bit of nice traction with federated learning.
Let's talk a little bit about open source. I know it's something you've been quite optimistic about, something where you feel open source AI is not only going to grow, but open source AI is going to be extremely beneficial. Explain how important open source AI will be in 2 years, and then also Facebook, or Meta, which has built the dominant model, Llama, will they still have the dominant model in open source AI in 2 years?
Meta did a really great job with Llama. One of the ways for AI to slow down is if there ends up being a very small number of gatekeepers. And frankly, I think one of the reasons the mobile space feels less innovative is because, frankly, there are two gatekeepers. And so you can't do certain things on mobile unless you get the permission. Open source AI is important to keep the space free, to let tons of people innovate whatever applications they want, and to let researchers study the models and keep scaling. I think Meta's done a great job, and I hope that they'll continue to keep doing the great job they're doing. People wonder why Meta's doing this. I think they're making a huge contribution to the world, and I'm really grateful to Meta for their open waste release of Llama. I think Meta has, very rationally been sensitive to having to build on someone else's platform. So I think we know that when iOS changes privacy rules, right, that can really hurt Facebook Meta's advertising business. So I think quite reasonably, Meta would be worried if it had to rely on, someone else's AI model. What if they change the rules and that hurts Meta's ability to build its business using these models? When my former team, Google Brain, released the TensorFlow deep learning framework, Meta, frankly, played their hand beautifully and released an alternative PyTorch as open source open weights. Because PyTorch was open, it really gained tons of traction and diffused, frankly, the competitive threat of TensorFlow, which came from my team, as a Google-controlled asset that Meta may or may not want to have to build on top of. And I see what Meta is doing for Llama as a great contribution, for which I'm genuinely grateful, but also a savvy business move by Meta to make sure that there is an AI model that is open, that they can build on top of and monetize other ways to make sure that there isn't a gatekeeper.
I mean, they have another huge advantage where they can afford, A, they have the money to spend on the chips, the fundamental cost, and B, if it doesn't pan out and they can't build a revenue stream or they decide they want to pivot, they can then take the chips and use them to power the recommendation algorithms on Instagram, whatever they want. They have a large enough company with enough optionality that they can hedge their bets somewhat. It's a remarkably savvy move by Meta. You're one of the very few people who has had the privilege of working both in the United States and in China on AI. I know it's been a while since you worked in China on AI issues, but explain a little bit about the differences in the way American researchers look at AI and the way researchers in China look at AI.
Gosh, yeah, it's been many years since the time I ran the AI team at Baidu. I feel like the China AI ecosystem tends to be very practical, very application oriented, amazing at engineering and execution, and really, really good at just trying tons of ideas over and over to find stuff that works. I think the American ecosystem is still better, I think, in certain parts of very deep research, which is why I think a lot of the deep tech AI innovations, had largely come out of the US. But China is probably not as far behind the US as people think. I feel like when I was at DC, people were saying, oh, maybe China is 1 to 2 years behind. I think China is maybe 0 to 6 months behind. And in some places, for example, video generation seems to be further ahead in China than in the United States. There's a very different flavor of work that's hard to explain. Very fast paced.
Does it seem possible that there will be a bunch of applications where maybe it is the case that large language models, for whatever reason, whether it's censorship, whether it's the deep tech that was necessary, where the United States will be ahead, but there's a whole bunch of other tech where, it'll be like drones, where China will massively surpass us, and whether that's in video generation, whether it's in robotaxis, whether it's in certain kinds of AI, whether it's in new things we happen to imagine. Do you think that that's how we'll end up shaking out?
It seems like there's a good chance of that. So I think to your point, I think AI isn't monolithic. There are different verticals of an AI. So for example, the surveillance technology is significantly more advanced in China than in the United States. And this has interesting effects. It means that when certain countries want to purchase surveillance tech, they will now buy from China and not from the United States vendors. China seems to be ahead in some parts of generative AI. I think because AI isn't monolithic, I think that it's quite natural that US and China may end up more advanced in different verticals.
Do you think that the China's advantage in surveillance tech, because it created so much video, led to their lead in video tech?
I think China's internal investments as well as internal market needs drove significant investments in technology. And so the technology advanced much faster in China, for good or for ill. And I think the US just had less of a market, less government investments. And then a consequence of that, which we can debate, what parts are good and what parts are bad. Clearly not everything is good or everything is bad. And as you mentioned, we've also seen drone technology is much more advanced in China than in the US. And maybe, there's a US trade embargo on GPUs on China is an incredibly leaky embargo. So yes, it does make it harder to get access to semiconductors in China, but probably not nearly as hard as a US government regulators, had wished their embargo had been.
I'm sure it's a lot leakier than the administration desire. Two last quick questions. You teach a lot. What advice do you give to young people going into the field of AI?
I think this is a wonderful time to build. AI technology is so new. Learn the technology, take control of it, and go build. I encourage everyone to learn to code because AI is so valuable and AI has also made it so much easier for people to code. On my team, I have investors and marketers and journalists that learn to code that are not doing software engineering jobs, but they're writing code to download web pages and generate marketing insights or automate generation of legal documents or whatever. But I think that AI technology is very powerful. I encourage everyone, young people, less young people, to take control of it. And in the future, one of the most important skills of pretty much every profession is to really take control of AI and get the computer to do what you want it to do. And one of the best ways to learn that still is to learn to code. So you really understand how this works and you can control it and direct it to your purposes, even if your job role is not a software engineer.
Yeah, that's wonderful advice. I also like your framing of young people in this. Young people, I am technically a less young person. Last question, what do you hope happens with AI in this coming year?
In the next 1 year, I think there'll be tons of applications. Maybe one challenge for AI is the $600 billion question. I'm seeing lots of green shoots where companies invest a much more modest amount, hundreds of thousands or billions of dollars is generating ROI. It's still a long way to fill that $600 billion hole, but I'm seeing more and more projects, really green shoots of real ROI. So I hope that will accelerate for AI. And then looking longer term, I hope we can make intelligence cheap. Today, one of the most expensive things is intelligence. It costs a lot to hire a doctor to counsel us on a medical condition or send a kid to hire a personal tutor to mentor our child because it costs a lot to train a wise human being. But with AI, maybe we can make intelligence cheap so that everyone can hire an army of smart, well-informed staff to help all of us with our needs in a way that has been accessible only to the relatively wealthy people. So if we can make intelligence cheap, we can make everyone's lives much better off.
And we can make the world more equal. All right, Andrew, thank you so much. It was a great pleasure to talk. Thank you so much for joining the show.
Thank you, Nick. Always a pleasure.
That was my conversation with Andrew Ng. I'm Nicholas Thompson, and you've been listening to The Most Interesting Thing in AI. Join us next week when we speak with Scott Likens and Heather Horn from PwC to explore the intersection of AI and sustainability. If you enjoyed what you've heard, like and review it on Apple Podcasts. Help spread the word about our series to other listeners like you.